So you want to visit the sun's core for 1 millisecond, just a tiny fraction of a second, in and out. How bad could it be? Well, let's think about what a millisecond actually means here. 1 millisecond is 1,000th of a second. That's faster than a blink, faster than a sneeze. You wouldn't even have time to realize what's happening. But the sun's core? It doesn't care about your schedule. Okay, let's set the rules. You teleport instantly to the exact center of the sun. You stay there for exactly 1 millisecond. Then you teleport back to Earth. The question is, what happens to your body during that millisecond? And more importantly, what comes back? First, let's talk about where you are. The sun's core is about 15 million degrees Celsius. For comparison, the surface of the sun is only about 5,500 degrees. You just skipped all of that and went straight to the nightmare zone. Now, at 15 million degrees, atoms are moving insanely fast. They're slamming into each other with so much energy that they fuse together. That's what powers the sun. Nuclear fusion. Hydrogen becomes helium. Energy gets released. Your body is also made of atoms, and those atoms are now surrounded by this chaos. So what happens first? Heat transfer. Heat moves from hot things to cold things, and you are very, very cold compared to 15 million degrees. The air around you on Earth is maybe 20 degrees Celsius. Your body is about 37 degrees. The sun's core is 15 million. The temperature difference is so extreme that heat doesn't just flow into you, it floods into you. Every molecule on the surface of your skin instantly tries to match the temperature around it. But here's the thing, your body can't absorb heat that fast without consequences. At those temperatures, the electrons in your atoms get ripped away. Your skin doesn't burn, it ionizes. You become plasma. Not the blood kind, the physics kind. Plasma is what happens when matter gets so hot that electrons leave their atoms. You stop being a solid, you stop being a person. You become a cloud of charged particles, and this happens in way less than a millisecond. We're talking microseconds, maybe faster. Okay, but let's say somehow your body holds together for the full millisecond. What else is happening? Pressure. The sun's core isn't just hot, it's also incredibly dense. The pressure there is about 250 billion times the atmospheric pressure on Earth. That's the weight of a mountain pressing down on every square inch of your body. Your lungs collapse instantly, your bones crumble, your cells rupture. Even if the heat didn't vaporize you, the pressure would crush you into a thin smear. But wait, there's more. Radiation. The sun's core is constantly blasting out high-energy photons, gamma rays, X-rays, all the bad stuff. These photons are flying around at the speed of light, smashing into everything. Your DNA, shredded, your cells, cooked from the inside out. Even if you were somehow protected from heat and pressure, the radiation alone would obliterate you on a molecular level. So let's review. In the first few microseconds, you ionize into plasma. Your body stops being solid matter. The pressure crushes what's left. The radiation scrambles your molecular structure. And all of this happens before even half a millisecond has passed. But here's the really wild part. You don't actually feel any of this. Your nerve signals travel at about 100 meters per second. That means it takes several milliseconds for pain signals to travel from your hand to your brain. You'd be vaporized before your brain could even register what's happening. One moment you're on Earth, the next moment you're a rapidly expanding cloud of ionized particles, and then you're back on Earth. Except you aren't coming back. What comes back is a puff of superheated plasma that used to be you. It would explode outward the moment it re-enters Earth's atmosphere. The air around it would ignite. Anyone standing nearby would have a very bad day. So, could you survive 1 millisecond in the sun's core? No, not even close. You'd be ionized, crushed, and irradiated in a fraction of that time. The only upside? You wouldn't feel it. Your brain wouldn't have time to process what's happening before it stops being a brain. So yeah, probably a bad idea.